Okay, so in this lecture video, I'll be discussing an example on circular object. Net torque pa rin siya. Ayan. Three forces are applied to a wheel of radius 0.350 meter as shown in the figure below. One force is perpendicular to the rim, so that would be the 11.19 Newton. One is tangent to it. So take a look at the three forces which is tangential to the rim. Okay, I hope you agree that it's the 8.50 Newton force that is tangential to the rim of the wheel. And obviously, the other one makes a 40-degree angle with the radius. What is the net torque on the wheel due to these three forces for an axis perpendicular to the wheel and passing through its center? So the axis of rotation for a wheel is obviously at its geometric center. Okay, let's choose our axis so that if we take this as x, this would be our y, and then the axis that cuts through the circle would be the z-axis. So if this is the center of the wheel now, let's sketch this axis as 90 degrees with the surface. So this is axis A, where the axis of rotation is located. So we have to determine where the axis of rotation is because uh, we are asked to solve for the total torque due to these three forces at, asan yung sabi niya? Net torque on the wheel for an axis perpendicular to the wheel and passing through its center. Because if the point of reference were another point on the wheel, then the total torque will be different. Okay? Why? Because again, torque is given by, let's have R cross F. So itong si position vector R, this is the magnitude of this is the distance between the point of application of the force and the axis of rotation. So if the axis of rotation here were not the center of the beam, let's just say the axis of rotation is somewhere here, then the torque of these three forces, the total torque of these three forces would be different. Okay? So that is why every time you're asked to determine torque, you have to take note also kung ano ba, saan ba ang location ng reference point. Because you can actually solve torque at any point reference. Okay, so please take note of that. Do not forget the definition of position vector R. Ayan, so yun yung meaning yan. So dito, ang point of reference natin is the center of the wheel. So let's remind ourselves that we are to determine the total torque as a vector because of the three forces. Ayan. Now, so let's take a look at, let's label the forces now. Let's take this as force 1. Okay. Let's take this as force 2. And this one is force 3. Okay. So, total torque. So, the summation of the torque here would just be the torque due to force 1 vector plus the torque due to force 2 plus the torque due to force 3. Okay, so isahin na natin siya ngayon. Si F1 here, this is the point of application of F1. This is the axis of rotation. So if we connect this, this will now be position vector R1. Now, obviously, sabi natin, we can use position vector R1 here as one of our axes to determine the parallel or perpendicular component of F1. So if that's the case, it's very obvious here that the F1 natin is also equivalent to F radial. Okay? Or we can also take say that it is equivalent to F parallel. Ayan. And si F1 tangential, this would be 0. Okay. So, wala din siyang F radial, no? Wala siya. Tama ba? Tama ba? F radial, F per, nalibog na hinoon ko. Sorry. So this one is F along the radius, so that's F rad, and F perpendicular. Tama ba? F parallel, tama. So, and then F perpendicular is also 0. So, since torque magnitude, the magnitude of torque is F R sine phi, we also know that it's F perpendicular times R, or F tangential R. So in this case, since F1 has no tangential and no perpendicular, then obviously there is no torque because of F1. Yeah? So it's just like the steering wheel that I mentioned earlier. If this is the manivela of your car, and then you push it, no, along the radius of your manivela, then it will never rotate. So pag wala siyang nakukos na rotation, wala siyang torque. So wag mo na isali. Let's go to torque due to force 2. So this is again the point of application. From the reference going to the point of application, this is now the position vector R2. Okay. We know very well that since this is a circle, we know that the magnitude of R1 is just the magnitude of R2 and the magnitude of R3, and these are all 0.35, the radius of the wheel. Maingay na naman ang dog ng kapitbahay namin. So, we can see here that F2 is really making a 90-degree angle with R2. So, that's maximum torque. So, we can say also that as a vector, itong si F2, entirely, the 8.50, everything is perpendicular to R. Tama ba? Or, this is entirely equivalent to F tangential. So, opposite siya sa F1. Kasi si F1, wala siyang perpendicular, meron siyang parallel. Pero dito si F2, meron siyang perpendicular, pero wala siyang parallel. So, this is F2 perpendicular and F2 tangential. And we can also sketch here that F2 parallel is 0. Or another way of looking, F radial is also 0. So, since that's the case, and we know that the moment arm L2 is just equal to R2, okay? So, merong torque dito si force 2, tama ba? So, if the wheel is being pushed upward, you know that F2 will cause this wheel to rotate counterclockwise. So, this will have a positive torque. Ayan. So, ito, positive pa rin siya. Counterclockwise is positive. And then, finally, si F3 ngayon, so let me erase this for a while kasi magulo. Yan. Si F3 ngayon, not all of the 14.6 value is tangential and not all of the 14.6 is radial. So, ano siya, na-distribute siya to tangential and radial. So, showing the components of F3 now, this would be from the reference. This is the point of application of F3. So, if we connect this would be position vector R3. If we extend or extrapolate R3 para mas klaro asan si F parallel, F perpendicular, we'll see here that from here to here, since this is along the radius, so this is F3 radial, which is also equivalent to F3 perpendicular. Yan. Tama ba? Radial and parallel. Parallel to R. So, this is F3 parallel. Kasi parallel nga, di ba? And then, this vector now would be the F3 perpendicular to R. Ito na siya, perpendicular to R. Or F3 tangential. It's tangential to the circular path. So, si F rad, this will have 0 torque. Ito lang si F3 perpendicular ang merong torque. Okay? So if F3 perpendicular is applied, it will cause a clockwise rotation of the wheel. So it will have a negative torque. So negative ito dito. Which reminds me of my error in the earlier video. Okay? So if you recall in my earlier video, sabi ko, pag counterclockwise negative, baliktad. Okay? If you notice, sinabi ko sa first na counterclockwise negative, pero nung nag-solve na ako, na opposite na ang nalagay ko, which is the correct one. So let me just put this straight to put it on record. Counterclockwise rotation corresponds to positive torque, and then clockwise rotation corresponds to negative torque. Okay? But, so kung counterclockwise torque, the direction of the torque would still be away from the plane, or it's going towards the observer. Pag clockwise rotation, it is towards the board. So the direction of torque, this is direction of torque, whereas this one is direction of rotation. So clockwise would be, this is the symbol for the direction, which is going towards negative z axis or negative k hat. Okay, bakit x? If you recall in vector product, we write x here, that's the tail of the arrow. If the arrow is moving away from you, what you see is the x tail. But if the arrow is going towards you, you see the tip. That's why ito yung ginagamit natin. So I hope that is clear. But the solution that I gave in the earlier video is correct. No? Yung nung inintroduce ko lang itong sign convention ang medyo nabaliktad. So let's go back here. So ito na siya, klaro na. Counterclockwise rotation because of F2, so that's positive. Clockwise rotation because of F3, that's negative. So we're ready to put the values now. Si torque 2, so torque 2 is, we can say it's F2 tangential times R2. And then this is minus F3 tangential tapos R3. Okay. But R2 and R3 are just the same. So let's put the values now. F2 tangential is just equal to F2. So this is 8.5 newtons times 0.35. And then F3 tangential, this is F3 is 14.6. Tangential, so it's sine 40 times 0.35. Okay, so therefore the total torque is equivalent to, bring out your calculator and paki-check, 0.5 times 0.35, 3.6 times sine 40 times 0.35. Uy, bakit na error? Let me pause for a while kasi okay, so the answer is negative 0.310. So the negative here, it means that the rotation is clockwise. So kung clockwise, the direction of torque is into the plane or away from the observer. Okay, so this is now our final answer. It means that, what does this mean? It means that the F3, the torque of F3 has won. No? So siya yung nanalo. Kasi when the three forces are applied at the same time, it will result to a clockwise rotation. So yung meaning to say, itong object na ito is not in equilibrium because the total torque is not zero. Okay? So in our next lesson on statics, for the second condition for equilibrium, the total torque must be 0. Pero ito dito, hindi siya 0. So, hindi ito equilibrium. Okay? Ayan. So, I have to stop here for a while. Do not forget to read your books and do not just rely on my lecture videos. I'll see you again next time. Stay well.